Electrical separation requirements for power quality meters are crucial for safe and reliable operation. The National Electrical Code, specifically Section 110.26 A1, mandates that electrical equipment must be installed in a safe and workmanlike manner. This general requirement underscores the importance of adhering to established safety practices during installation. Furthermore, Section 300.3 C1 addresses the specific issue of conductors with different voltage ratings. It states that these conductors must be separated by a distance of at least 1 foot unless a barrier is installed between them. This regulation aims to prevent electrical arcing and potential hazards arising from voltage differences. ANSI/IEEE Standard C37.91 provides additional guidance for power quality meters. Section 5.1.2 requires that power quality meters be installed in a manner that maintains a minimum clearance of 1 foot between high voltage conductors and communication or control wiring. The standard emphasizes the need to isolate sensitive communication circuits from high voltage sources to minimize interference and ensure accurate data transmission. Now, let's consider the specific case of the GE Nexus EPM 9650Q meter. While the GE installation manual for this meter does not explicitly specify a minimum separation distance between high voltage and communication wiring, it's important to apply industry best practices and relevant standards. Based on the NEC and ANSI/IEEE C37.91 requirements, it is highly recommended to maintain a minimum separation distance of 1 foot between the 480 volts alternating current conductors and the Cat5e communication wiring on the GE Nexus EPM 9650Q meter. There are several ways to achieve this separation. Firstly, you can mount the meter further away from the switchgear. Increasing the physical distance between the high voltage conductors and the communication wiring naturally reduces the risk of electrical interference and potential hazards. Secondly, you can install a barrier between the high voltage and communication wiring. A physical barrier provides an additional layer of insulation and protection, preventing accidental contact and minimizing electromagnetic interference. Thirdly, consider using shielded communication cables. Shielded cables offer enhanced protection against electromagnetic interference, ensuring the integrity of the communication signals. Failure to maintain proper separation between high voltage and communication wiring can have serious consequences. Electrical interference and noise can disrupt communication signals, leading to inaccurate readings and unreliable operation of the power quality meter. Damage to the communication cabling is another potential risk. Exposure to high voltage fields can degrade the insulation of the cables, potentially causing short circuits and communication failures. Safety hazards, such as electrical shock, are also a significant concern. Improper separation increases the risk of accidental contact with energized conductors, posing a threat to personnel. In conclusion, to ensure safe and reliable operation of the GE Nexus EPM 9650Q meter, it is essential to maintain a minimum separation distance of 1 foot between the 480 volt alternating current conductors and the Cat5e communication wiring. Adhering to the NEC, ANSI/IEEE standards, and implementing practical separation techniques will help prevent electrical interference, protect communication cables, and safeguard personnel. Remember that electrical safety is paramount, and taking the necessary precautions is always the best approach.